Since the 1960s, all equipment for a mission has been mounted atop a single rocket. Over the years, missions have gotten more complicated, and the payloads have gotten bigger, requiring a bigger rocket. Mission planning is constantly bumping up against rocket size and weight constraints. Assembling in space relieves the bottleneck at the top of the rocket. Regular launches from anywhere in the world deliver components to a construction yard in space, where robots assemble the final product autonomously. If a component doesn't make the launch schedule, it can catch the next flight. If something breaks or a rocket is lost, a new piece can be shipped and replaced instead of scratching the whole mission. More advanced components can continue in development while other parts of the mission have already left the ground. Autonomous in-space assembly is a new paradigm for constructing spacefaring equipment. The A-Train is a possible first step en route to a flexible and robust in-space assembly ecosystem. Currently, the A-Train is a constellation of separate satellites, orbiting in a line and viewing the same spot on Earth one after the other. Hosting these many satellites on a single platform would dramatically decrease the cost of science by providing common utilities like large data downlinks and power from solar panels. Additionally, simultaneous satellite observations would create higher quality data. The modularity of A-Train allows for a pay-as-you-go investment approach. Base components, like trusses, can be assembled on orbit, while mission-specific instruments are launched in a traditional manner, spreading infrastructure costs over a series of missions. Autonomous in-space assembly can make A-Train a reality. Tools such as Ninjar can precisely position components for joining. The Talisman arms have the strength to grasp and move large objects and the dexterity to place them in an exact orientation. The construction tool set is reusable, repositionable, and expandable over time. As capabilities expand and throughput increases, more ambitious projects farther from home become feasible. Human construction and repair requires the added expense and effort of human habitation in space. Structures can be built faster and cheaper by robots. Only later, once life-supporting habitats have been built, do humans arrive for their mission. As we move further out into space, the challenge will only increase. A new day is dawning. Technological advancements are making previously untenable projects feasible. Before long, autonomous in-space assembly will be the norm, allowing us to tackle the largest space construction jobs envisioned. 22nd century in-space exploration.